In this video, we're going to talk about measures of spread, which I mentioned briefly in the last video when we talked about the box and whisker plot, introduced the IQR and the range. So we'll get more in depth into that stuff in this video. So the first thing I want you to realize is, why do we need to look at IQR? So IQR helps us identify what's called an outlier. So an outlier, you can see right here is an extreme value that's much less or much greater than other data values. And that's actually something interesting to consider, because that could skew your data. So let's say, you've got a bunch of people in class who are just about, 5'7", and then you have one person who's 7 feet tall, like Mr. Han. Then that's kind of an outlier. It makes our average height look like, everyone's 6 feet, but really most people are about 5'7", and just Mr. Han is 7 feet tall. So it's interesting to look at that, because sometimes we want to exclude outliers from our data to help get a better sense of, the general population or the general trends. And then we can, of course, explore outliers on their own and see, well, why is there one point that's super high or super low compared to everything else? So lots of interesting things we can explore with data. So one way we can determine the outlier is to basically do this calculation. We're going to look at 1.5 times the IQR, and we're either going to go below or we're going to go above. And that'll tell us super, super small points or super, super big points compared to the rest of our data, and then we'll identify those as outliers. So for example, if we look at this, what we want to do is we want to find the IQR first, and then figure out if we do have any outliers. So we want to find out those boundaries for what would be considered an outlier. So remember, to find the IQR, we want to find Q1 and Q3. So the first thing we want to do is split our data in half, and this is already nicely organized from lowest to greatest. So I'm going to go ahead and count to my middle to find the median. All right, and then what you'll notice is in this situation, we actually have an even set of data values. So what's nice about this is you can see, okay, I split this up into half. So I've got 5 here on the left and 5 here on the right. And because we don't have a single median value we take from the data, we're just basically going to cut each group, right? Each half into half, and then that's going to be our Q1 and our Q3. So with my first list, I have 4, 5, 6, 6, 7, and from here I'm going to go ahead and count to my middle, and there's a clear middle value. There's Q1. And that second list, we have 8. Oh, sorry, that's a bit fat. All right, let's try that again. So we've got 8, 8, 9, 10, and 16. Same deal. Let's go ahead and count to that middle. And then we have a very clear winner. There's that middle value. There's 9. That's my Q3. So then I can go ahead and find my IQR. Remember, IQR is Q3 minus Q1. So that'll be 6. Oh, I was about to do Q1 minus Q3. Be careful. So that's going to be 9 minus 6, which is 3. So then we want to find the boundaries. Basically, what would be the lowest value that wouldn't be an outlier, and then what would be the highest value that wouldn't be considered an outlier, and then we know, right, beyond that would be outliers. So we're going to do 1.5 times the IQR. So that's going to equal 1.5 times 3. So 1.5 times 3 is 4.5. So then for the lower limit, I'm going to do Q1 minus 1.5 times the IQR. So that is just, excuse me, 6 minus 4.5. So anything below 1.5 would be an outlier. And then we can do the same thing for Q3, but Q3 we're going to add to 1.5 times the IQR because we want to look for bigger values, right? So 9 plus 4.5 is 13.5. So basically our outliers are going to be less than 1.5 and greater than 13.5. So now if we go back and look at the original set of data, we want to see, is there anything less than 1.5 Well, no, our lowest number is 4, so we're good on the lower end. But on the higher end, you might realize, wait a minute, 16, that's huge. 16 is bigger than 13.5, so we do have an outlier. So 16 is an outlier because it's greater than 13.5. All right, so you do want to make sure you show all of your work. So I want to see how, right, you got your Q1, how you got your Q3, and then of course your steps to your outlier. And you don't have to split it up into 2 steps like I did here. I just want to show you that 1.5 times the IQR was that key value. You can just do, Q1 minus 1.5 times 3 and get the same value. But anyway, like I was saying, this actually affects our spread. So here's just something to note, that if we were to plot the original box plot, and ooh, that pen is super fat too. Let me just change that setting. If we were to plot the original with the outlier, our 5-number summary, I'm just going to put it in a set, would be our minimum of 4, a Q1 of 6, a median of 7.5, Q3 of 9, and a maximum of 16. Oops. Let me be consistent. So that's a set, so we want to use a curly bracket. So this is my 5-number summary. So if I were to plot that, that would be the original box plot. Now compare that to what the 5-number summary would be without the outlier. So then that would become the same minimum 4, but I take out the 16. So then my Q1 becomes 5.5, my median becomes 7, my Q3 then becomes 8.5, and my maximum is no longer 16, but it's 10. So you can already see that the data is already a little different, and I actually plotted this on Desmo, so let me show you what that looks like right here. So this is without the outlier in blue, this is with the outlier here in black. So you can see how different it is. It's more symmetrical when we take out the outlier. So just that one value skews everything kind of upwards. So you can see what I was saying, by being able to identify outliers, it's actually interesting because actually everything but one point is basically summarized here in this blue plot, which tells you it's much more symmetrical. And there might just be this one outlier that's throwing off all our data. So that might be an interesting thing to research and look into, but also think about, well, why is everything else pretty symmetrical? So anyway, just something to consider, because with statistics, we don't want to just look at the numbers, but we also want to think about the interpretation. That's why we have so much stats out in the world. So let's go back to our notes and go ahead and try that you try. So if you want to pause right here and try out that you try problem on your own, go for it. Just like in the last video, I'm going to come back and show you the answers to the you tries after I finish all the notes. So if you want to pause right here, try the you try, and then wait till the end to check your answers, go for it. Otherwise, we're going to keep going on to talk about standard deviation. Okay, so standard deviation, you might remember from Algebra 1, but if not, no worries, it was a while back. But remember, standard deviation is also a measure of spread. So what it is it is the square root of the variance. And variance is the average of the square differences of the mean from the mean, which probably doesn't tell you too much about what it does. But if you think about variation, it tells you basically how much variation, right, is in the data. So what I want you guys to kind of remember is this important piece. If we have a low standard deviation, that means our data is clustered near this measure of central tendency. So for example, you might have all of your data points really, really close to the mean. That means there isn't too much variation, like we're all around the same height. Versus a high standard deviation, right, tells us we've got, ooh, that's cool. Anyway, that indicates that we are spread out from the center. So we're really far spread out, meaning we have a lot of variation. Like maybe we have some people who are 4 feet 11 inches tall, and we have some people who are 7 feet tall, and a lot of people in between. So that tells you basically how much our data is basically varying, right? And it's an interesting piece of information because, again, remember with stats, we want to think about what it means. So we want to think, is it tightly clustered? That means there's not a lot of difference, right, differentiation in the population or in the sample population, versus there's a lot of variation, right? We have multiple ethnicities or multiple heights and things like that. Okay, so one quick note, this isn't super important for you guys to know, but we have 2 types of standard deviation. One is called population standard deviation and one is called sample standard deviation. This formula that we're using is sample standard deviation, which means it's really, typically it's really hard to get everybody's information. Like you can think there's a 2020 census going on right now in the US, but are we actually going to survey every single person who lives in America? No, it's super difficult to get every single person. We're going to get as many as possible. So we get a kind of subset, like a sample of the overall population. And then we can find the standard deviation of that sample, which is this formula here. Or we can try to approximate that to the population standard deviation. And that the only difference is sample is 1 over n minus 1, population is 1 over n. We're going to use sample because sample is typically what you see more people using. Oops, I'm clicking everything. So that's what we're using. But I just want you guys to be aware there are two, and there are, minor difference between the two. So sample is just for the subset, right? The little group that we're working with. Population is kind of the estimate for everybody in that entire population. So anyway, how do we do this? First thing you want to do is understand what all this means. So n is the number of data points. So that's basically how many people or how many items are in your sample. That's n. X bar is the mean. S stands for standard deviation, sample standard deviation, and then X is, of course, your data point. So we have some steps we're going to follow. We're going to find the mean first, because you can see we need the mean, and then we can just break this down with PEMDAS. Don't forget the sigma stands for sum. So we're going to be summing up all the differences of our point from the mean squared, so the squared differences from the mean. So we want to find each of these, think about PEMDAS. If you want to figure out what the mean is, then we can do X minus X bar, then take each of those and square it, add them all up, multiply it by 1 over n minus 1, and then square root that whole thing. So let me just write that out for you really fast. All right, so there you go. 6 steps just to find standard deviation. Make sure you know we memorize this because you need to figure out standard deviation by memory without our notes. So just keep that in mind. Okay, so calculating mean, we know that that's the average, right? This is our average. And then data point minus mean, this is that X minus X bar business. And then squaring each step and each answer in step 2 is that X minus X bar squared. So you can see we're basically just working inside out. We're going to sum all of our answers in step 3. So that means we're going to take all of these X minus X bar squareds, add them all up. Calculate the variance. Variance is just that sum that we did in step 4, right? The sum from step 4 divided by your n minus 1. That's your variance. And then we're just going to square root that to get our answer. So what might help is to create a little table to at least do the first 3 steps. So that way it's all pretty clear what you're doing. And then we can calculate the sum and all that. So here's how I would make my table. So we have each data point, so which we'll call X. And then we want to first, right, find your X bar, and then we can do X minus X bar, and then we can do X minus X bar squared. So that kind of organizes what I'm doing. Okay, now let's actually find our mean so we can fill in our chart. So to find my X bar, I'm just doing 6 plus 8 plus 7 plus 5 plus 9. Divide that whole thing by 1, 2, 3, 4, 5, right? So my average is going to be 7, right? Because that'll be 35 over 5. And then I have 5 data points. I have 6, I have 8, I have 7, 5, 9, and there's my X bar. And you don't actually have to put in this second column. I put it in so it's really clear to me what I'm doing. I'm doing 6 minus 7, negative 1, 8 minus 7, positive 1, 7 minus 7, 0, and you get the idea, right? And then what we're going to take is we're going to take each of these numbers and square it. So make sure you square the actual value. Negative 1 to the second power is positive 1, right? 1 to the second power is 1, 0 squared is 0, negative 2 squared is positive 4, 2 squared is 4. So then what we want to do is basically take this last column and find that sum. So 1 plus 1 plus 4 plus 4 is 10. So that is step 4. Then step 5, we're just going to take that sum over n minus 1. So 10 over 5 minus 1 is 10 over 4, or 2.5. And final step, standard deviation S equals the square root of 2.5. That's your exact value. Let's say we want to round that to the nearest thousandth. It's going to be about 1.581. There you go. That's standard deviation. So go ahead and try the U-tries. We'll come back and check the answer. Okay, so pause right now if you are trying out those U-tries. Otherwise, I'm going to scroll back up so we can start checking our answers. So pause if you're trying. Okay, let's check. So going back up to that first U-try problem, finding the IQR, identifying any outliers. Remember the three important pieces, Q1, Q3, and then you take Q3 minus Q1 to get IQR. So you want to split your data in half, either excluding the median if there's one median value, or including the two values to calculate the overall median if you have an even number of values, right? And then we want to calculate the boundaries for our outliers. So remember that's 1.5 times the IQR. We're going to subtract that from Q1 or add it to Q3 so we can see, okay, outliers are less than 5.5 or greater than 25.5. And then we can determine, hey, look, 3 and 28 both are outliers. Make sure you're being careful and you're explaining how you know, because remember, communicating your knowledge is the most important piece. So that's the first U-try problem. Then scrolling all the way back down to the U-try for standard deviation. So remember, you want to remember your process. So if you calculate the mean, we should get 72, right? Then doing each data point minus the mean. And it's totally okay that X is not in order. We really only need it in numerical order to help us find median and mode. Otherwise, we can just kind of put it in. So don't worry about reorganizing X here. And then we can see we did X minus X bar, squared that difference, summed it to find the variance, square root of 104 over 3 is 5.888. Here's that important piece I was telling you guys before. Don't round too early. We round once, and here we're rounding to the nearest thousandths, just to be consistent with everything else we've done. But 104 divided by 3 is a non-terminating decimal, right? So we don't want to round that first and then round again. So leave it as 104 over 3 and square root that entire value in your calculator to get that 5.888. Okay, so that's going to be really important. Remember, we round once, just at the very end. All right, so that wraps up all of SA1. So we talked about measures of center and graphical representations in the first half, and we just finished off with measures of spread. So make sure if you have questions, you do ask. Otherwise, thank you for listening.